Good morning. I am Dr. Senthil Kumar, Associate Professor in the Department of Agricultural Engineering. Let me discuss about the topic liquid fuels in the course Heat Power Engineering for the 5th semester Agricultural Engineering students. And we know the basic classifications of fuels as solid fuel, liquid fuel and gaseous fuel. And in case of liquid fuel, the important liquid fuel are the petroleum products, tar, alcohols. They are naturally found under the sealess surface. Liquid fuels are also obtained synthetically from hydrogenation of coal. Liquid fuels finds extensive use in domestic and industrial fields. To say about petroleum, it is a common term that is used to mention the products which is obtained from the nature. Petroleum or crude oil is a dark greenish, brown or black colors viscous oil found deep in earth's crust. The oil is usually floating over the brine solution, and above the oil, natural gas is present. Crude oil containing mixture of paraffinic, olefinic and aromatic hydrocarbons with minor amount of organic compounds. Classifications of petroleum. Petroleum is classified into three types based upon the variation of chemical nature of crude oil found on the earth, that is paraffin base, asphaltic base as well as the mixed base. And let us see about the extraction of petroleum. And we used to say this process is the fractional distillation of petroleum. The crude oil obtained from the earth's crust consists water, sulfur and some unwanted impurities. After removal of water, sulfur and these impurities, the crude oil is separated into various useful fractions by fractional distillation and finally converted into desired specific products having different boiling point. So the process is called refining of petroleum, and the refining plant is called oil refineries. The process of refining involves the following step. The first step is the separation of water, and the process we used to term it as the Cottrell process. The crude oil from the oil well is an extreme stable emulsion of oil and salt water. The crude oil is allowed to flow between two highly charged electrodes where colloidal water droplets to form large drops, which is then separated out from oil. And the second process is the removal of harmful impurities. The presence of NaCl, MgCl in the crude oil corrode the refining equipment, hence these also removed by electrical desalting and dehydration methods. The sulfur compounds present in the crude oil is removed by treating oil with copper oxide, which results in the formation of copper sulfate, which is then removed by filtration process. Let us discuss about the fractional distillation of petroleum. This is an important process in which we get the various products at various boiling point, and by means of condensation we get the various products. The crude oil is then heated to about 400 degrees Celsius in an iron retort chamber, whereby all volatile substance except asphalt or coke are evaporated. The hot vapors are then passed up to the fractionating column, which is a tall cylindrical tower containing a number of horizontal stainless steel trays at short distance. Each tray is provided with small chimney covered with a loose cap. We can see in the diagram in the next slide. When the vapors of oil goes up the fractionating column, they become gradually cooler and get condensed at different heights of column. The fractions having higher boiling point condense at lower trays, whereas the fractions having lower boiling point condense at higher trays. The gasoline obtained by the fractional distillation is called Stryten gasoline. Various fractions obtained at different trays are given below. This is the chamber, and you can see here it is a tall stainless steel chamber. You can see the crude oil. The vapor it is sent to this left side shows the inlet portion where it is sent inside in the form of vapors. It is heated in the furnace at a temperature of 400 degrees Celsius, and the vapor enters into this fractionating column. You can see at the various levels, depending upon the boiling point, it gets condensed at various levels. So as I said earlier, it will be collected in various levels like lubricating oil, diesel oil, kerosene, naphthalene, gasoline as well as petroleum ether. And you can see heavy oil will be collected in the lower bottommost portion, and vapor which did not get condensed goes outside as here gases, where we are using it as the domestic LPG gas. These are the various products which is obtained at various temperature. So uncondensed gas, that what I said, which the vapors which does not get condensed and goes outside as a gas. Its boiling range will be below 30 degrees Celsius, and the composition of hydrocarbons is C1 to C4, and the uses to say as domestic and industrial fuel under the name LPG, whereas the petroleum ether, its boiling range is between 30 to 70 degrees Celsius, and the hydrocarbon that is containing is C5 to C7. It is used as a solvent. And the next level is the gasoline or the petrol, where the boiling point is 40 to 120 degrees Celsius, and the hydrocarbon is C5 to C9. It is used as a motor fuel in automobiles, solvent and dry cleaning. And naphtha 120 to 180 degrees Celsius, we are using as a solvent and dry cleaning. Kerosene oil, the boiling point is 180 degrees Celsius to 250 degrees Celsius. We are using as a fuel for the jet engines and as illuminant. Diesel oil, where the boiling point is between 250 to 320 degrees Celsius. We are using as a diesel engine fuel. And the last one is the heavy oil, which we collect at the lower bottom portion of the furnace. That is, the boiling point is 320 to 400 degrees Celsius. It is used for the production of gasoline by cracking process. And the various fractions received by heavy oil is shown in the images also: grease, asphalt, bitumen, etc. To say another one thing, that is knocking. Knocking is a kind of explosion due to the rapid pressure rise occurring in an IC engine. In a petrol engine, a mixture of gasoline vapor and air at a ratio of 1:17 is used as a fuel. The mixture is compressed and ignited by the electrical spark. The products of oxidation reaction, that is combustion, increases the pressure and pushes the piston down the cylinder. If the combustion proceeds in a regular way, there is no problem in knocking, but in some cases the rate of combustion will not be uniform due to unwanted chemical constituents of gasoline. The rate of ignition of the fuel gradually increases, and the final portion of the fuel air mixture get ignited instantaneously, producing an explosive sound known as knocking. Knocking property of the fuel reduces the efficiency of the engine, so a good gasoline should resist knocking. And to say about this, the improvement knocking characteristics as well as the chemical structures and knocking. The knocking tendency of the fuel hydrocarbons mainly depends upon their chemical structures. The knocking tendency decreases in the following order: that is tight chain paraffin, followed by branched chain paraffin, cycloparaffins, then olefins as well as the aromatics. And the improvement of anti-knock characteristics, the octane number of the fuel can be improved by blending petrol with high octane number with petrol of low octane number. That means blending the gasoline or the petrol of low octane number with high octane number, so that the octane number of the latter can be improved. The addition of anti-knock elements like tetraethyl ether, that we used to say it as a TEL, addition of TEL. In general, we used to say that is a unleaded petrol, like that we can see in the petrol bunks also. Leaded petrol, anti-knock agent. The anti-knock properties of gasoline can be improved by addition of suitable additives. That is, tetraethyl lead is an important additive added to petrol. Thus, the petrol containing tetraethyl lead is called leaded petrol. TEL reduces the knocking tendency of hydrocarbon. Knocking follows a free radical mechanisms leading to a chain growth, which results in an explosion. If the chains are terminated before the growth, knocking will cease. TL decomposes thermally to form ethyl-free radicals, which combine with the growing free radicals of knocking process, and thus chain growth is stopped. And to save the disadvantages of using TEL, when the leaded petrol is used as a fuel, TEL is converted to lead oxide and metal oxide. This lead deposits on the spark plug and on wall mounts, which is harmful to the engine life. To avoid a small amount of ethyl dibromide is added along with TEL. This ethyl dibromide reacts with Pb and PbO to give a volatile lead bromide, which goes out along with the exhaust gas. But this is the atmospheric pollution, so nowadays aromatic phosphates are used instead of TELs. Nowadays aromatic phosphates are used as anti-knock agents because it avoids and leads pollution. Thank you for watching this video. Thank you, Ananda.